Welcome to the demo of Memgraph Lab 3.3. In this latest release, we rolled out some exciting new updates, and one of the biggest highlights is the completely revamped GraphChat. GraphChat now offers an even more powerful and intuitive way to explore your graph data through natural language. Whether you're asking questions or diving into graph insights, it's smarter, faster, and more helpful than ever. Let's take a look at what's new and how it all works in action. To get started, we will first install Memgraph MAGE and Lab. We will do that by running these two simple commands, which will pull and run the latest Docker images. The handling of the quick connect in Memgraph Lab differs based on the operating system, and since I am on Mac, I need to set quick connect environment variable to host.docker.internal. As you can see in the Docker desktop app, we now have Memgraph MAGE and Lab containers running. To check whether the connection works as expected, head over to the localhost 3000 and connect to running Memgraph instance. Head over to the GraphChat to add LLM connection and explore its new features. There are two prerequisites. Have graph schema procedures, and for the most performant option, I have run Memgraph with show schema info flag enabled. The other prerequisite is to have a populated database. Today, I will demo on the pre-prepared dataset in Lab. Let's find the Europe Road Network dataset and load it. The dataset is now loaded, and we can go back to GraphChat. Now, let's add a new LLM connection. First, you need to select a provider. I will go with OpenAI option. For that, I need to have OpenAI API key ready. Then I click on the Configure Model button. Here, I can see all options available to configure the OpenAI model. I can give it a name, limit the number of previous exchanges GraphChat includes to provide context-aware responses, limit how many tool-based reasoning steps GraphChat can perform when answering a question, and other model parameters. I can also change LLM permissions and add additional context. Additional context allows you to add instructions, background information, or example queries to improve responses. For now, let's leave everything as is and start the conversation. This is the chat interface. On the left-hand side, we will have all threads listed. Currently, we are using OpenAI GPT-4 model. If you'd like, you can add additional provider or model to compare the responses. To chat, we input the text at the bottom. Let's kick it off by first asking how many nodes are in the dataset. You can see the assistant responded, and you can expand the answer to check what exactly happened in the background. You can see the steps the assistant took to provide the answer, number of tokens and tools used, schema used, and context used. By clicking on the schema used, you can see how the schema that was sent to LLM looks like. By clicking on the context used, you can see the full context provided in the prompt to the LLM. Notice how Assistant used one tool. In the previous versions of Lab, GraphChat would take your query, send it to the LLM along with the context to translate it to Cypher and run it in Memgraph. Now, the assistant can select tools to answer your question in the best way possible. To see the list of all available tools, click here. This is the LLM Toolkit. It consists of tools that allow the LLM to query your graph, retrieve storage info, and run built-in algorithms like PageRank. You can define your own custom tool or enable built-in tools. By default, all built-in tools are enabled. Let's see them in action. Before, the assistant responded to the question, how many nodes are in the dataset? To respond, it chose Show Storage Info tool. This tool runs Show Storage Info query in Memgraph and returns the information on vertex count. which probably helped LLM to quickly figure out the exact number of nodes in the database. Now let's head over to the next example. Let's ask another question. Tell me more about my dataset. As you can see, now we are using one previous exchange. This actually means that the LLM took the previous answer and question into account when answering this question. You can change the setting on how many previous exchanges LLM is going to use by clicking on the settings here. Here, you need to define max previous exchanges to make sure you include more or less previous exchanges. As you can see, LLM responded to the question really well, and it gave us information on nodes, relationships, indexes, constraints, and triggers. Let's see how it figured it all out. To give the proper answer, it actually used 4 different tools, as you can see here. So it used Show Schema Info tool, Show Indexes tool, Show Constraints, and Show Triggers tools. Here you can also check the raw response that we got from the LLM. Now I want to explore my dataset a bit further. Let's see what countries we have here. List countries from my dataset. So I got a lot of countries here. Let's see how LLM concluded that. So it ran this query with the run Cypher query tool, and it actually matched all countries and returned its names. So I guess we have all of the countries here, and I'm mostly interested currently in Italy. So let's ask, to which cities is Italy connected to? Let's see if it can figure it out. Okay, it provided me with an answer, but of course, it's like a black box if I can't do this. Now, when I expand, I can see that it actually took into account the schema it has, so it was able to match a country and a city and connection between them and return the city name. So I will kind of trust that, okay, these are the cities that are connected to Italy in my dataset. I like Verona. So let me see if I can find out more about Verona. Tell me more, or tell me something about Verona. I got some information on Verona. I got the information about which city it is connected to, and here are some of them. And then I have the information that each connection typically has 2 roads, since this is a Europe road network, makes sense, except this one, which has 1. Okay, let's see how it concluded this. So it actually tried running Cypher query, but it wasn't well generated, and this ended up with error. But that's fine because there is an error handling here and retry. So it actually retried this tool with another query. And this time it got a proper query that resulted in a proper response. And in the end, it managed to get this response to me. Okay, so I like that, but I kind of want to find out more if possible. To do that, I will define my own custom tool. To define my tool, I will head over to the LLM toolkit and click on Create Custom Tool. First, I need to give it a name. This name should be good enough that LLM can kind of figure it out when it should use this tool. So I will name it Get Extra Node Details. Then I need to provide a description. The description here will be tool gives details for a specific node by node ID. It returns all two hop edges and nodes around the input node, which gives a better picture of context information. After that, I need to provide the actual query in Cypher that is going to be run in the background. So let's do that. And here I'm just doing a simple traversal BFS from one node to another, and I'm matching the ID of a node to the parameter node ID. So in order for this to work, I need to still add a query parameter. Here, I need to input node ID as a parameter name that is being used above in the query. The type is integer. And then I need to provide a description for that parameter. In this case, the description will be node ID to get the context for. Should be integer, can be fetched with ID node variable. Okay, I guess I gave it all of the necessary instructions, and I'm going to click on Create. Once I created my tool, I can see it here listed. I can see it is enabled, and I can always edit it, or I can delete it. I can, of course, add a new tool as well. I can see now that I have 10 out of 10 tools enabled, since I added a custom tool along with 9 built-in tools. Okay, let's now ask a new question in a new thread just to have a clean slate and see whether our tool is going to work. So I'm going to ask LLM to give me extra details on the city Verona. I got the answer. So Verona is a city in Italy connected to various other cities through a network of roads, and I got some details about the connections and the road connections and how long they are. Let's see how LLM generated this answer. So to do that, LLM actually first called a run Cypher query tool, and it did that in order to detect what node ID is of the city Verona. So then it used my tool get extra node details, what I wanted, and it actually included this node ID it found out from the previous tool run. Once it did that, it obtained all of the information around the node Verona up to 3 hops, and with the help of that, basically provided the full answer that we got in the end. So this is a really nice use case for the custom tools, but you can do much more advanced things there. Now I'm going to give you a bit more insights into how additional context works. To show you the value of additional context, I open up a new thread and I'm going to ask a question. What can you tell me about city of 7 hills? Okay, it seems that there is no information about the city of 7 hills. That's because LLM tried running this query and it actually didn't find a city of 7 hills. Okay, let's help LLM a bit. Here, I'm going to define additional context and I'm going to say, when asked about city of 7 hills, search for Rome. Okay, let's ask the question again. Now it actually knows that it's a nickname for Rome, and then it figure out more information from its own knowledge. But I would like to know more about this city from the database. In which country is the city of 7 hills located, and to how many roads it is connected based on the data in the dataset? Okay, it says that it is located in Italy and connected to 28 roads. Let's see how it figured it out. So now this time it actually ran Cypher query again, but it took Rome as a name, which is correct. And then again tried to find the roads that are connected to Rome, and it provided the answer. So that's what I actually wanted. I wanted to somehow give the LLM information on what I'm referring to. Let's now combine a bit all of that we have. And let's head over to our settings. Let's delete this additional context, do not have one. We have the clean slate here. We have all of the 10 tools enabled. That's what I wanted. And let's ask, tell me more about my favorite city. Okay, so LLM can't tell me more about my favorite city because it, of course, doesn't know which city is my favorite one. So now I'm going to tell it my favorite city is Berlin. Okay, let's now ask, give me extra details about my favorite city. Okay, so I got the answer that Berlin is a vibrant city with numerous connections to other cities through a network of roads. So I got all of the direct road connections, country connections, extended connections, cultural and economic hub information. Let's see how it figured it out. So first it runs Cypher query to get to the node ID of Berlin. So it knew it had to take a look at Berlin because Berlin is my favorite city from the additional context. Then it decided to use get extra node details. And the reason for that is because I asked, give me extra details about my favorite city. In order to use this tool, it needed to obtain the node ID. It got that correctly, and ended up listing all of the things important to Berlin that are actually 3 hops around the city of Berlin. And then with all of the context used and that information, it actually generated this response. So I guess you can see from this how defining custom tools using built-in tools, using additional context and previous exchanges can actually be really helpful when communicating with your dataset. That's it. I hope you liked this demo and that you enjoyed seeing GraphChat's tool-first approach, where LLMs use a set of Cypher-backed tools. This offers a safer and more scalable alternative to letting LLM directly generate Cypher query from natural language. Hopefully, new features will give Memgraph developers better control, improve performance, and ensure more consistent results. Happy natural language querying!